Well, morning and welcome to podcast 4. And today I'm very pleased to have Ian Riley, the CEO of the World Cement Association, with me. Ian, I do this every time. I say I'm going to ask you to introduce yourself. I introduce you, but perhaps you could give a little background to your role in the association and also the association itself.
So good morning, Alex, and hello to everyone. My name, as Alex said, is Ian Riley. I'm the CEO of the World Cement Association. And we represent cement producers around the world, but also other stakeholders in the cement industry. So engineering companies, technology providers, suppliers, and so on. And we really have three ambitions. One is to be the voice of the industry, so including cement producers and the other stakeholders. Secondly is to help our members improve their operational performance and their profitability. And thirdly is to accelerate the decarbonisation of the cement industry. So I'm delighted this morning to have a chance to talk to you about this third topic.
Brilliant. And accelerating decarbonisation, as you know, is our tagline as well. So we're definitely sort of working from different ends of the same issue. So that's great. So today we're going to sort of talk about a few things, but let's kick off not with technology. We will come on to technology, and obviously that's where the focus often is when you talk about decarbonisation. But let's just start with a kind of a big question, which is, tell me a bit about your sense of what is needed from both the industrials dealing with this issue, but also policymakers. So let's start with that. What's your view on what's going to drive net zero?
Yes, so if we go back 20 years, more than 20 years now, the cement industry, or 10 large companies within the cement industry, set up something called the Cement Sustainability Initiative under the World Business Council for Sustainable Development. And so this was a long time before there was any great pressure from society or policymakers to do this. But the cement industry recognized that the impact on the environment, particularly CO2, but not only CO2, other emissions, safety record, was a key issue that they should seek to improve. So they set objectives for improvements versus 1990. And most of those were targets that they aimed to achieve in the last few years, 2015 or so. Mm-hmm. And I think almost all of the players achieved those targets that they set. But if you look at that was a little bit low-hanging fruit. So in the cement industry, as we'll talk about in a bit more detail later, I'm sure, there are some things that you can do to reduce carbon emissions that also reduce costs and improve profitability. So those are really sort of no-brainers. They require some investment in many cases, but those are things that can be done that are in everybody's interest. But as you progress on that, then there are more trade-offs. And so then the policy environment really becomes very important. And it's actually very difficult to get policies to work in the way that they're supposed to. I think that the ETS in Europe is an example of this. And in fact, WCA will be organizing a podcast that will come out in a few weeks' time, specifically looking at this issue. But there's quite a lot of evidence that the ETS for the cement sector has not reduced carbon emissions over the last 20 years or so, and possibly has even increased them.
Why is that? I mean, any policy, any rule, anything always has an unintended consequence. Of course, it's just life, isn't it? But why particularly with ETS has it delivered those kind of perhaps increases?
I think that the problem with the EU system, or the ETS system, is that you have to have 28 countries agreeing to any changes. So they had a lot of political negotiations at the beginning over who would receive what quotas. And having finally agreed that, it was pretty much impossible to change. But as a result of the financial crisis in 2008, so shortly after the scheme started, the environment changed, and the amount of economic activity, and particularly in the cement industry, was significantly reduced. So all of the players had excess credits. And the excess credits were maintained so long as the plants operated at least 50% capacity. So there was an incentive to keep the inefficient plants running. Had there been no ETS, then a lot of the older plants would have been closed down, and the more efficient plants with lower carbon footprints would have continued to operate. So in a nutshell, that was the issue with the system. And it shows some of the difficulties in anticipating how things will really work out. I think the EU has a particular problem because of the number of nations involved. But any multilateral scheme, and the most effective schemes are likely to be multilateral, are going to have that kind of problem.
So what next then? I know there are no simple answers to this, but if you were going to sort of point to perhaps a couple of things that would make a difference, if there are policy influencers or makers, listening to this, I'm sure they won't be surprised by what you're going to say, but what would you say? What do you think we need to see?
So I think there are two different approaches. And one approach is essentially the approach that the Europeans have been considering, which is you price carbon. So whether that's a trading scheme or a tax, there are pros and cons for either one. But if you can design it so that it does deliver the policy goals, then you can clearly provide incentives to reduce carbon. Effectively, what you're doing is you're putting a price on dumping CO2 into the atmosphere. So that's really what we need to do to create the incentives to drive behavior more quickly. So that's one way of doing it. Another way of doing it is something that we've seen in China, and maybe the best example of this is actually not on CO2, but on NOx reduction, because air pollution in China has been a big issue for many years now. And the Chinese first established the technical feasibility of the requirements that they were putting in place, and then they mandated extremely strict limits on all of the cement plants. So they came down from an initial limit of 800 milligrams per normal cubic meter down to 400, and now in some places it's as low as 100, and even talk that it might go lower. And some of the best producers are down at 25, 30, a level we thought was impossible a few years ago. So that's pushed technology. There are various technologies that are involved, but that's pushed technology forward. But the technology existed before those requirements came into play. So I think with CO2, the challenge with that approach is today there are some technologies that we know how to use, but to get down to zero, we need new technologies. So mandating lower limits today would be rather ineffective.
Yes, it's a tough one, isn't it? Because you sort of, anytime I have these conversations, I think immediately to what do people outside of the industrial sphere see when they look in, and what they see is resistance, or what they see might be a kind of pushback against what is necessary. But it's not as simple as that, is it? It's you could come up with a whole load of simple rules that still don't get you to the actual outcome you want, which is carbon neutrality. And I think kind of showing what industry is up to is sometimes the hardest bit of this, because it can seem like there's just resistance or passivity sometimes. But that brings me on to my next question then. So there's
if I could just say something on that. I think the other context that we should think about is concrete is used in huge quantities. So cement is used basically in concrete, and concrete is used in huge quantities around the world. About 90% of it in the developing world. So in most of these countries, the idea that they would have to pay 2 or 3 times as much for their cement is not going to fly unless there's a large amount of external funding from first world countries. So I think when we look at what is a feasible decarbonisation strategy for the industry or roadmap for the industry, it has to take place at reasonable cost. Otherwise, it won't be something that is accepted worldwide.
Well, let's have a kind of a look then. There's so many. One of the big surprises for me coming into this sort of end of last year, I suppose, was you read a lot about, well, cement is responsible, concrete's responsible for whatever it is, 7 or 8% of global CO2. So my assumption was, well, we must make sure they do something. Well, that's not the issue. There are plenty of projects. It's just kind of, I guess everything's at a fairly early stage. But you tell me, what's interesting, what's kind of emerged as projects, or what projects have emerged, sorry, in the last couple of years or last year or so that have really interested you? What do you see kind of coming up that you think, yeah, that's a kind of technology, or that's an approach I want to keep an eye on?
So there's one particular project which is also slightly representative of some similar approaches. And this project, well, it's not really a project, but it's a product that has been developed in Switzerland called LC3. So LC3 is a cement that reduces the amount of clinker in the cement. So clinker is the part of the cement that is responsible for the vast majority of the CO2 emissions. So this is what you get when you burn limestone. So it reduces the clinker in a CEM1, a top grade cement, from about 95% down to about 50%, with the addition of kaolin, metakaolin, so calcined kaolin and limestone. So of course there's a slight carbon footprint with the calcined kaolin, but it's much, much lower than it is with the clinker. So the net impact of that is a very substantial reduction in the CO2 footprint of the product. Now, it's difficult to get new products accepted in the construction industry because people quite rightly worry about buildings falling down and bridges falling down. This is obviously not a good thing. But I think that these approaches are quite robust. We understand why they work. We understand at a sort of a macro level and a microscopic level why they work. And metakaolin and limestone have been used in cements for a long time. But it's the synergistic effect of using them together in the ratios that are involved in LC3 that is giving the good performance. So this is something that the industry has been talking about for a few years now, but we started to see the first projects in Latin America and in West Africa. There have been new plants constructed that are producing LC3. And I think this is something that will accelerate and will have a big impact on the carbon footprint in certain countries.
I should just say at this point that if you're listening to this and you can hear mad squeaking in the background, it's not Ian. It's not even Ian's chair. It's that they're based in Paddington. So the happy world of London is I guess we'll take it as a good sign, as something that's kind of coming back to life. But that's what that is. Okay, so that's one kind of project. What else? Are there kind of other either technologies or even approaches that you see members taking that you think warrant a second look or warrant being highlighted?
Yes. So if I can get on to how we decarbonize the cement industry, then maybe that will put it in context for the question. So we've had three main levers to reduce the carbon footprint of cement that we've been working on for many years now. So the first is energy efficiency, and so I should start by saying that of the emissions in cement, about round numbers, about 60% come from the calcination of the limestone, about 30% from the fuel burnt in that process, and about 10% from electricity, primarily used in grinding the raw mill and grinding the finished cement. So when we look at the energy efficiency levers, we're talking about the 30% which relates to fuel and the 10% that relates to electricity. And so there's a lot of work that's been done on that. I guess if you looked at the global industry, there's probably been 20 to 30% improvement in that area over the last 20 years or so. And there's been new kiln technologies that are now widely used, and a series of improvements in milling technologies that have improved efficiency. So certainly when it comes to new plants, then that's a very easy decision to make. Of course, you use the newest technologies and have the lowest energy efficiencies. So we now see a situation where the industry in China and in India is much more efficient than the industry in Europe and America. So that probably surprises some people, but there's quite a substantial difference. But even for the Indians and the Chinese, if you compare the average with the newest plants that are being built, there's quite a gap. Yeah? So there is still quite a bit we can do in terms of energy efficiency. The difficulty there is that it requires capex. That it requires investment. So there are some things where the investment payback is relatively quick, and we should be doing those. But the big things, it's pretty hard to justify on existing plants. Sorry, Alex.
No, it was fine. I was just interested. So, in energy efficiency, I mean, there are all kinds of ways that different companies pursue this. What are the kind of main things you're seeing? Is it kind of digitizing and sort of bringing in more automation, or what is it that's really driving that in the cement sector?
Well, we are seeing that now, but what has driven the big improvements in energy efficiency is changes in the pyro technology, so the kiln technology, the preheating technology, the energy recovery technology. So it's really that thermal process efficiency.
And would I be right that, so I know you want to talk about other aspects as well as energy efficiency, but it sounds like, so most of the gains there, it's not necessarily been specifically about decarbonisation. It's actually just been, this is something we need to do for operational efficiency and to improve our margins. So a happy outcome of thinking in that way has been to reduce.
Yes, the two go absolutely hand in hand. So the projects that have gone ahead have been justified on financial basis. So it's not been, okay, we're saving carbon, so we can do this. It's this will save carbon, but it gives us a reasonable return on investment, so we can do it.
I know when we very first spoke, you were talking, and this was back in February. Yeah, I remember you talking about alternative fuels and some of the challenges around that as your next bucket of things that the industry needs to look at. So, tell me a little about what's happening there.
Yeah, so the idea with alternative fuels is really twofold. So one is it's a way of reducing fuel costs. Yeah? And again, a lot of the things that have been done have started from that motivation. I recall that there were objectives of some of the players in the industry 15, 20 years ago of having zero fuel costs. And so the idea was that you would replace coal, usually coal, not always, but usually coal with waste materials, and you would get paid for burning the waste materials so that you would be able to get down to zero fuel cost. I don't think today anybody believes that's possible, because the value of waste has increased because more people are trying to reuse waste. But it still can be cheaper than coal. So there's still that financial incentive of using waste versus using fossil fuel. But today, of course, it's become much more of an issue that we want to reduce the carbon footprint. So the carbon intensity of coal is very high. And if we can move away from coal then without incurring extra costs, then that's a very good way of doing it. I think the other thing is that burning waste is providing a service to the economy and society in general. So one of the alternatives is you can burn the municipal waste in a cement plant. And because of the higher temperatures and the way it cools, you don't get the same problems. So you don't get dioxins generated. And of course, you've got a vast quantity of clinker going through. So the increase, you don't get the concentration of heavy metals that you do in the bottom ash of incinerators. So it's also a lot cheaper to do it safely. So the cement industry is providing a service to the cities of disposing of their municipal waste. The other thing that is one of the traditional levers in the third traditional lever is clinker factor. So this is very much the LC3 story. So if you can reduce the proportion of clinker in cement by adding other cementitious materials, then you can reduce the per ton of cement emissions. So this is something that there's been a fair amount of progress. We use a lot of the slag, for example, so a waste material from the steel plant, from blast furnace steel making. In many countries, quite a lot of fly ash is used, so from the coal-fired power stations. There's an issue in terms of fly ash quality, so the proportion of fly ash used is much lower than slag, but there's still quite a bit used. Natural pozzolans in some countries where you have volcanic activity where you have the natural pozzolands. There are a variety of cementitious materials, and a lot of the cement used in most countries around the world is a blended cement. So it has the other cementitious materials with a portion of clinker. And the clinker, the overall clinker factor has come down over the years. So that's one of the levers of reducing the carbon footprint.
And so that one we might sort of term a kind of a product shift rather than an
Yes.
operational.
Yeah.
The first two are kind of more how the facilities run, the operational strategy, and this is a product-based strategy.
That's right.
So you introduced me to Blue Planet as an example. Would you fit? Do they fit here, or do they fit?
No, they fit later.
Okay. Sorry, I'm jumping ahead.
So in terms of cementitious, this is actually quite an interesting area. I mentioned LC3 earlier, which is really quite an exciting product. And so there are some countries where you don't find traditional cementitious materials. And I was talking to EBRD recently, and they've been working with the Egyptian cement industry and the Egyptian government on helping them to change the product codes to allow LC3 to be used. And in Egypt, you don't have fly ash, you don't have slag, you don't have natural pozzolan, so their average clinker factor is extremely high. And so LC3 in Egypt will make a really big difference because they do have kaolins, which is the raw material in Egypt. They do have limestones. So the raw material is locally available and will allow them to reduce their clinker factor very substantially. In some countries, the clinker factor is already fairly low, so the impact will be somewhat less. But I think in all cases, there is some reduction potential.
It's kind of fascinating, isn't it? What a difference. I mean, I know it's the same for many industries, that regional variations, regional supplies and things like that make such an impact. But here,
yes, absolutely.
Your natural geography, isn't it? And
yes,
what's available.
Yeah. So Egypt is one example. Another example is one of our members, OYAC, well, one of their subsidiaries, Simpo, has built a plant in West Africa, in Ivory Coast, which is specifically to produce an LC3 cement. Because in West Africa, there's very little limestone. And so all of the clinker has to be imported. And so you can replace imported clinker with locally mined and produced metakaolin. So that is also interesting. It also reduces the quantity that has to be shipped and so on. It has foreign currency impacts. It helps balance foreign currency and so forth. So you see that there. So I think areas which are short of limestone are also extremely interested in LC3. So there's a range of different kinds of geography where this is a very attractive option.
And I know kind of last and a growing area, but still relatively small in impact at the moment for cement, are the kind of newer technologies, particularly carbon capture. What are you seeing that interests you from those newer technologies for your sector?
Well, perhaps just before we move off the cementitious materials, some of the new technologies are affecting cementitious materials as well. For example, there's a company in the US called Solidio who has a different kind of cement which uses CO2 to cure it rather than water. So it absorbs a considerable amount of CO2 in the curing process. But because it requires high concentrations of CO2, it's limited really to precast. So the majority of cement is used in ready mix. And so that's been a limitation. But they've now developed essentially a cementitious additive based on their cement technology, which allows it to be used in ready mix. So there are some new technologies in that cementitious area, not just LC3, but a number of others that are looking at other ways of producing replacement products for clinker. One of the limitations is always, how much of the raw materials do you have? Because there's perhaps 40 to 50 billion tons a year of ready mix, of concrete, that is used, you have to have huge quantities of the raw materials, otherwise it's not going to work. So that's always one of the things to balance. But the biggest area where new technology is making an impact, as you say, is in carbon, really carbon usage, I suppose, is the specific area. So we've got carbon capture, which of course is common to many industries, and the percentage of CO2 in the stack from the cement kiln is perhaps 20% or a bit less than 20%. So this is kind of in the middle of the range. You know, there are some plants, chemical plants, that are much higher than that. There are some power plants that are much lower than that. So it's a fairly typical challenge for a carbon capture technology. And, you know, there are a number of different carbon capture technologies that are being looked at, but these aren't specific to the cement or the building material industry. So lots of other people can talk about those in much more detail than I can. But the thing that's interesting with building materials is the potential for usage. And it's really because of the quantity of building materials, heavy building materials, concrete that is used, that we have this potential for using carbon in these materials. So Blue Planet, as you mentioned earlier, is a company in San Francisco. And what they're doing is they're taking a carbon source or a CO2 source from a natural gas power plant and injecting it into a calcium slurry. And the calcium slurry comes from demolished buildings, and they essentially acid wash this to produce more or less a virgin aggregate. And then with the remaining calcium slurry, they react it with CO2 to produce a synthetic aggregate. And so this is absorbing CO2. So that's quite interesting. The economics of this, they say works in San Francisco, but San Francisco is a little bit of a special case because aggregate prices in San Francisco are very high, because normally the aggregates come from a long distance away. And I think they're getting the CO2 and the construction waste at no charge. So that might translate to European cities. So London, for example, the aggregates also come from quite a long way away and are also pretty expensive. So, you know, maybe there are other opportunities, but you really need some carbon incentives to make that more generally viable.
Create a market for it. Yeah.
But there are other approaches here. So we have another member, Carbon Cure, that is absorbing CO2 into ready mix, and
I think they've been in the news a lot recently, haven't they, with the investment?
They have, yeah. No, they've been very successful in expanding the usage of their technologies. So the amount of CO2 that's absorbed is quite modest, but because it improves the quality of the ready mix, it means that you can reduce the cement added to the ready mix, and that's where the majority of the CO2 saving comes from. So it's a more efficient way of making concrete from cement. And then we see other approaches to making cementitious materials more effective. So there are companies that are treating fly ash to make the fly ash better quality and therefore to enable greater usage. I'm talking to somebody later this week who has a technology that activates pozzolans, again with the same idea of making them more effective as a cementitious material and enabling increased usage. So there's quite a lot going on in basically in those two areas, one in cementitious and one in carbon usage.
When you look at the projects that are working, what are the hallmarks of the cement manufacturers and their behavior, their culture that's helping that project forward? Because I think when I look across projects, you can see that there are certain types of businesses that can just help these projects move forward, and they seem to get, you know, their culture and their organization behind it. Tell me a little about what you're seeing. What is it that you're learning about how we create more successes in these areas?
So we can probably put these technologies into two buckets. So there's one group that is coming from within the cement industry. So Solidia, LC3, you know, these are part of the cement industry, let's say. And then there's another group which are coming from tech startups, you know, where people have got together specifically to absorb carbon, you know, to use carbon and so forth. So these two groups have quite different characteristics, I think. And it's a bigger challenge for the second group, I think, than the first group, because the first group is already a little bit embedded in the system. But the cement industry is very conservative, and it invests for the long term. So it has very much a long-term thinking. And I think to be successful in heavy industry, that's essential. So it's not that we can get away from that too much, but it does mean that change comes fairly slowly. What would make a difference, I think, is if there were stronger incentives to replace carbon, coming back to what we talked about at the beginning. If you have a carbon price that is significant and is worldwide, then companies will be incentivized to do things that at the moment are just costing them money. If you look at what's happening in Europe with experimentation on carbon capture and storage, this is obviously a lot of that is funded by government grants and subsidies, but the cement companies at present are not really gaining from that. So they think, okay, long term, there's a potential, there will be a carbon price. The ETS will, in the next phase of the ETS, it will start to become more beneficial if you can reduce your carbon footprint. But I think that the speed at which those new technologies are embraced is really a function of incentives.
Is there a challenge for other forms of funding? I mean, I say that, I'm pretty sure I know the answer is yes, because most industries say there is. But so to what extent is there funding from either capital markets or the kind of, I don't know, venture and private equity for cement companies to form projects around this? Is that a challenge, or is that money there as well?
Well, there is interest on this. So I think a lot of the existing carbon capture and storage projects have received a lot of money from governments, and that's how they've continued. But there is interest, for example, in funding pipelines for the storage. So the carbon storage is primarily in old oil reservoirs. So in a lot of cases, you've got pipelines that are coming from the oil fields to the markets. And if the oil fields are exhausted, then you could use those pipelines with quite a lot of work, but you could use those pipelines to put the carbon back into the ground. So there is some interest in funding those kind of mega projects, and I think it remains to be seen whether they're viable. Personally, I think a project like that involves a huge funding for a pipeline system does have a risk of being overtaken by newer technology that has a lower cost of disposing of the carbon. Now, whether that proves a barrier to realizing that funding remains to be seen, but I think it's clear that there is that technological risk to such projects.
There is one other question I was hoping to ask you, which is something that has come up quite a lot as we were building the festival, was this question of, but who's going to buy our slightly more expensive, lower carbon or carbon-free product? And a number of sectors have been asking, what is the market for products that maybe will cost more, but they achieve that goal of being more sustainable and potentially carbon neutral. Are you and your members, is that a concern, or are you seeing that the kind of construction sector will step up and pay that bit more? Tell me a bit about your perspective on that.
Yeah, so I mentioned earlier about the need for the regulatory incentives, and of course the other alternative is you have consumer incentives. Where the customers are saying we must have product that is low carbon. So we aren't seeing that really in any quantity. I mean, it's very, very niche. So a lot of the major players have green cements, but the quantities that are being sold is very small.
Limited.
And it's largely for government or government-funded buildings where that's been, something that they've said, okay, on this building we're going to use, low carbon cement. The exception seems to be in Sweden. In Sweden, I was talking to Skanska a few weeks ago, and they were saying that there's really quite a premium that people, ordinary consumers, are willing to pay for low carbon construction, low carbon building. So there does seem to be, some examples of where a green product commands a premium. But I think by and large, we haven't seen that.
Okay, well then, kind of the final thing from you. What we've talked about a number of things, from the technology to the incentives that are going to be essential. But your absolute gut feel, Ian, what's it going to take? What do you think the kind of 2 or 3 most essential next steps are, if both the cement sector and those looking at it and hoping it will make these steps in decarbonisation, what's going to need to happen?
So the cement sector has been reluctant to make commitments because today we don't have the technology to completely decarbonize. Yeah? So the commitments today have been a commitment to reduce the specific emissions in cement. And I think we can get away from that. And there's a few examples now of companies that have got away from that. But what we've been saying as an association for some time now is that we can see a way of substantially reducing our footprint over the next 10 years using existing technologies, the levers that we know how to pull, and some of the new technologies that are most advanced, like the LC3. So we can make a concrete commitment to a certain reduction over that period. And we know these technologies are being developed. There's lots of technologies that are being developed, some of which we discussed today. And I think we have to make a commitment to achieve decarbonisation by a given date, even though we don't know what the last part of that journey will be, because that will then mobilise resources and we will start to take more seriously the opportunity to decarbonise. So we've seen with Dalmia Cement, for example, in India, that they made a commitment a while ago to achieve zero carbon, well, negative carbon, they said, by 2040. And more recently, at the beginning of the New York Climate Week, we saw a commitment from Lafarge Holcim to reduce to zero carbon by 2050. And then, of course, later that week, we saw the commitment from China to decarbonize the whole economy by 2060. So I think we start to see more commitments being made. But I think that for the cement sector, we should be saying concrete targets for 2030, and then, a commitment to achieve the decarbonization, but that part of the roadmap has to be defined later. And what we will hope to see from government in the interim is an increase in the incentives to invest in these new technologies and to decarbonize.
Thank you very much for joining me today. I was very grateful for your help early on in the research for our festival and the work that we're doing. And anyone that's listening, as Ian mentioned, they are about to launch their own sustainability podcast. I'll put the link to the association in the podcast notes, but you can go there and keep an eye and sign up for their podcast shortly. Thank you very much.
So Alex, thank you very much.
All right, take care.
Bye-bye.